Ocean currents transport heat throughout the globe, but as climate change melts sea ice and causes more rain to fall, a major current circulating thr. Read more. Would the world really face chaos if the Atlantic's ocean currents slowed down? Recent studies have suggested the water continuously flowing around the Atlantic Ocean could slow as the climate warms, potentially triggering global weather consequences. It is indisputable that climate change is being fueled by greenhouse gases, but what is less clear is where the tipping points may reside. Breaking points where slowly building changes push parts of the climate system into a dramatically different state, with potentially chaotic and troublesome consequences for the planet. One of those tipping points relates to the Atlantic Meridional Overturning Circulation, or the AMOC, a giant oceanic conveyor belt that redistributes heat around the planet. A recent eye-popping study suggested that the conveyor could effectively shut down as soon as 2025, perhaps triggering sweeping shifts in Earth's weather patterns. This study on AMOC, and mentions of the related, but different, Gulf Stream, soon appeared in apocalyptic-sounding articles, and an AMOC shutdown has even been used as the plot driver in the movie The Day After Tomorrow, featuring a world in which much of the northern hemisphere is covered in lethal ice. The exact details of tipping points like an AMOC shutdown have scientists concerned. They are not just worried about what is known, but what isn't, and that's plenty. We worry that there are processes that will come and surprise us, says Andrew Watson, the head of the Marine and Atmospheric Science Group at the University of Exeter. But what exactly is the AMOC? How does it affect the climate? And are we all in trouble? Here's everything you need to know. Running AMOC. The AMOC is somewhat comparable to a conveyor belt, one that transports warm water and life-supporting nutrients from the tropics to the North Atlantic. The physical properties of water make it excellent at trapping heat captured via sunlight, explains Penny Holliday, head of marine physics and ocean climate at the National Oceanography Centre in Southampton, England. And heat moving on this conveyor belt influences the climate, particularly around the Atlantic Ocean. This movement is fueled by changes in salt and temperature. As warm water flows north, it evaporates, which increases its salt content. When this belt of water approaches the more frigid northern reaches of the Atlantic, it also cools. The decreasing temperature and rising salt content makes the water denser, causing it to sink as it heads back south, all while subtropical water keeps on heading north, continually fueling the conveyor. But that once dependable process may be changing. The world is rapidly warming, particularly at the poles. Scientists suspect that this may affect the AMOC. As the current moves north, less evaporation occurs, and more fresh water is injected from heavier rainfall and melting sea ice. That dilutes the current, making it less dense, enough to still sink and head south, but more slowly than before. At least, that's what one theory suggests, and indeed what some computer models predict. But forecasting the future isn't that simple. The AMOC isn't a river of warm water. It's not like the diagrams at all, says Holliday. And it is difficult to extricate the AMOC from the rest of the climate because it doesn't exist in isolation. Nevertheless, we definitely know that the AMOC is a potentially unstable system, says Watson. One capable of slowing down, perhaps to a crawl or standstill. Looking for clues in our prehistoric past. Climate records preserved in Greenlandic ice indicate that Earth's last ice age saw about 25 periods of sudden climatic changes, abrupt temperature spikes over a matter of decades, followed by gradual cooling, in the North Atlantic. The region also experienced several extremely cold periods between some of these warming events. The causes of both are still debated, but paleoclimate evidence suggests that melting ice injected an abundance of freshwater into the North Atlantic, diluting the AMOC enough to slow, or even shut it down, causing significant cooling across the North Atlantic. Nobody can be sure what a major AMOC slowdown would do to the climate of today's world. Less warm water may be supplied to Western Europe, but the overall effect of global warming would probably have a bigger impact on the region's weather. Rain belts may be globally redistributed, causing droughts in some parts of the world but upping the downpours for others. Nobody knows anything for sure, sadly. A future AMOC slowdown would happen within other parts of climate change, says Levke Caesar, a climate researcher at the Institute of Environmental Physics at the University of Bremen in Germany. We don't know which effect is going to win. Hunting for hints in the Atlantic Ocean. So, is a slowdown likely, or perhaps already happening? A recent report by the Intergovernmental Panel on Climate Change, a United Nations group that continually assesses climate change science, considers a shutdown this century to be unlikely. Several studies have suggested that a slowdown has begun in recent years, but not all scientists concur on the extent, or the existence, of a long-term slowdown. One of the reasons there is so much uncertainty over the AMOC is because data is limited. The AMOC has only been continually monitored in one form or another since 2004. Because AMOC transports heat, scientists have frequently used sea surface temperatures to determine its speed. Some scientists have suggested that the sea just south of Greenland could hold clues about how this oceanic movement is changing. This region, unlike the rest of the North Atlantic, has remained relatively cool, and this unusually cool spot conveniently has data going back to 1870. Watson says this anomaly shows that something is afoot in the North Atlantic, and some scientists wonder if this may be a sign of the AMOC's faltering health. It was data from this northern Atlantic Ocean region that the authors of the most recently published AMOC paper used to run a statistical model to predict how unstable the AMOC can get before it malfunctions and shuts down. They concluded that a shutdown could occur somewhere between 2025 and 2095. Peter Ditlevsen, a researcher at the Ice and Climate Group at the University of Copenhagen and one of the study's co-authors, says this projection is not conclusive by itself. But, it adds to the alarm, he says, the concern that a major slowdown or shutdown cannot yet be ruled out. This kind of tipping point analysis is mathematically sound, but you need to have a long record, says Watson. And not everyone thinks this region's temperature is a useful AMOC vital sign. I have colleagues who are skeptical that that's actually going to tell them what the AMOC is doing, he says. The days after tomorrow.